Okay, so we have new topic now. That's the spherical coordinates system. Okay, so let me just decorate something. Spherical coordinate system. You can give the heading spherical coordinate system. Now, sphere. Why we are doing this? Basically, if I give you the question based on the spherical coordinate system, it's not spherical. It's just spherical. Okay. So, do you know what is the spherical coordinate system? Have you heard or have you learned anything about this before? Like polar coordinate system, we have
So
done.
far, we've been doing, yeah,
Like polar in 3D or
polar.
Hmm. So, okay, let me draw the spherical coordinate system here. Uh, just a second. So, this is our z-axis. This is y. This is x. Okay. So in this case, we have a point P on sphere. You can assume. Okay, and this line makes an angle phi with z-axis. Okay, the projection of this line is drawn on xy plane, which is this. Okay, this is the projection of this line OP on xy plane. Okay, so the length of this is denoted by r, the length of OP is denoted by rho. This line O, like the line R, makes an angle theta with x-axis. Okay, so this is the whole arrangement. If I draw the sphere here, you must have remember our old friend, the football. It's like going from our, it is with us from the first lecture. I'm not able to find now.
Yeah.
So if I draw that football here, okay, how would I draw? Like this is the circle, okay, and then I'll draw its latitude like this, okay, and we can draw the longitude also, okay. So this is the longitude of this football. I purposely use the term latitude and the longitude. So this green circle is longitude, and the circle going like this vertically, it's latitude. So line OP makes an angle phi, okay, with z axis, and the projection of
so
line,
the opposite.
sorry,
So isn't it the opposite?
No,
Like
it's right.
latitude, the horizontal one.
No.
I'm not
Latitude.
sure. I'm asking.
Yeah, no. Latitude is connecting to pole.
No. So it's wrong.
It's wrong.
It's latitude is the one which is flat, meaning, and then longitude are the longer lines.
Are you
Yeah,
sure?
it's
The
Yeah,
Because
sure.
yeah,
no.
The equator is a latitude line.
Because I also
Yeah,
searched something
yeah.
on like
Latitude, yeah.
see the latitude is goes
latitude is that.
all the
Is
way
that.
all around, and latitude, see, longitude goes all the way around, and latitude, can you see that?
no, sir.
No,
Not
you
visible.
can't see.
Okay, just a second.
Both go all the way around, no?
So
Yeah.
both go all the way around.
Both
No.
go
In
both
math,
way.
in maths, I want to explain you in maths. Like here, the thing is, we are going to take uh, phi and theta. The range of phi and theta are different. Okay. So just a second, I share you something here. See here, can you read this? Longitude goes all the way around, and latitude goes from pole to pole. And the reason is because you will double count. So that's that reason I will explain you. Okay. See, the phi is from 0 to pi, and for theta it's from 0 to 2 pi. So basically you have doubt in this line, no? Longitude goes
No, pretty
all
sure
the way.
latitude is horizontal. So we
Your
learned it in school also later on.
Yeah.
latitude is horizontal, and longitude is like this, vertical.
Hmm. Hmm.
Okay. Okay, so we have to basically we have to.
Latitude goes
Mhm.
from pole to pole.
Yeah, so that what that
I
what
think that means that every
see, pole is
that
here,
the
no?
latitudes go
See,
from pole to pole. So it's like that.
yeah, so pole is here, no? We have
The
north
pole
and
are the
south
two
pole.
endpoints.
See, latitude goes from pole to pole, right? And we have north and south
So
pole.
in
So this
so
is
you can
north.
just search for this thing,
Hmm.
the diagram
Hmm.
online.
Hmm.
Hmm.
Search it out. Search it out. You can share also. What Mano is showing. Let me just zoom it. Longitude is vertical line. Latitude is horizontal. It's switched off. But it's, can you like reverse it, like it's
So
ups
what
and
they
down.
mean from
It's
pole
ups
to
and
pole
down.
is what they
Longitude.
mean is upside down. What
Yeah,
happened?
on screen. No, your the picture is ups and down basically.
I can see it straight. Maybe is it?
Yeah, so this latitude is from horizontal. They are showing north to south. So latitude is north to south, no? And longitude
So what
is
they mean when they say pole to pole, maybe
hmm,
what they mean from pole to pole.
hmm,
Is it visible? Yeah.
yeah, it's visible.
Is from pole
Just
to pole
check
this way.
WhatsApp. So check WhatsApp.
Okay. So like pole to pole is longitude, and parallel to equator, like horizontal is latitude.
Hmm. Latitude. Yeah.
So that's like from geography, maybe. Maybe okay. I should not use this term here. For instance, okay. Stop sharing this, Mano. Let me maximize my page.
Yeah.
So I should not write these terms here, but definitely maths will make sense here. What I mean to say is our phi, okay, that's phi is going from 0 to pi, okay, and theta is going from 0 to 2 pi. So, like, if you understand this sphere, okay, so one is going like along this line, so the point is always like making angle phi. Are you getting that? So these are the angle phi, which is make with z axis, okay. So it goes from 0 to pi, and if you go in the opposite direction, so it is again with the angle made by the line with z axis, okay, like this. So this is phi. So it means the phi is going from 0 to pi, and theta is going from 0 to 2 pi, because the theta is basically this circle, okay, that round, this complete circle. So that makes sense, because this is like spherical coordinate, so we should understand the sphere first properly, and then we can write down the coordinate system, okay. So like along this pole to pole, okay, now I'm not using the term latitude here. It's, if suppose we are going from pole to pole, hmm, so the point traveling from pole to pole will make an angle with z axis, okay, and that is called as phi here, okay. So if you go in opposite direction, that also will make an angle with z axis, and the extension of the angle is from 0 to pi, and like around this line it is going from 0 to 2 pi. So that's the basically the objective of my discussion, that theta is going from 0 to 2 pi, and the phi is going from 0 to pi, okay. I don't know what I found this line from internet only, so it may be with reference of this spherical coordinate system, because I purposely typed the spherical coordinate system and then I found this. So in that case the latitude and longitude maybe makes different sense, okay. So see, I'll share that page with you also. You will find that the latitude goes from pole to pole. So it may be with respect to the spherical coordinates. Are you getting that? Hmm? Don't confuse with the terminology. So we should not use the term latitude and longitude here. Nevertheless, the phi is going from 0 to pi, and theta is going from 0 to 2 pi. Okay. So what would be the say the length of OP is rho here. Okay, let me write this as P prime. What is the projection of OP on Z axis? Can you find out that?
Mm,
What is the projection of OP on Z axis? Means cos
okay. It's cos phi
cos phi is
mod
equal
OP.
to Z upon rho, right?
Yeah. Correct.
Hmm.
Yeah.
I didn't draw that. So cos phi is equal to Z upon rho. So Z coordinate is rho
Hmm.
cos phi. Okay. And what about this horizontal line here? That horizontal line will be rho cos phi, isn't it? Rho sin phi, isn't it? Hmm? That would be rho sin phi, opposite, opposite upon hypotenuse. Are you getting
Yeah,
that?
Yeah.
So that horizontal line is nothing but this r, because that's the same. The projection of that horizontal line is nothing but this blue line. Okay, so r is also rho sin phi. Okay, That's the can you imagine the diagram properly? So the projection of that, let
Yeah.
me write the name. The projection of PQ is nothing but P dash O. Okay, so it will have same length. So OP dash is also rho sine phi. It should be rho, not reversing. Okay. Now, what would be x since we got this as rho sine phi? What would be x and y coordinate?
Yeah, so that would be the R normal, right? R
Yeah,
cos
yeah.
theta.
X, see, x is equal to r cos theta. The angle made by the line with x-axis is theta. So x is equal to r cos theta. But what is r? R is rho sine phi.
Yeah,
So r cos theta, right? R is sine phi. And what is y? Y is equal to r sine theta. So rho sine phi sine theta. And what is z? Z is rho cos phi that we already found here. So these are the spherical coordinate system. X is equal to rho sine phi cos theta, rho sine phi sine theta, z is equal to rho cos phi. Did you understand this? Okay. So
yeah.
see, phi is going from 0 to pi and theta is going from 0 to 2 pi. Now I have sent one picture on WhatsApp. Please read that. So and let me know what they are saying. So they have already used the term latitude and longitude. I was also not sure about the terminology, but the concept is pretty sure. Right? So maybe there may be some confusion here about the term, but I think the idea was to explain you about the range of phi and the range of theta. So is that clear with you now?
Yeah.
Okay.
Mm.
Because see the phi is going from, see the phi is the angle made by the line, the point, the connecting point with origin with z axis. So basically it will go from 0 to pi. If you go in opposite direction, then also it will count with the z axis. Are you getting that? The angle made by z axis. So it will again go from 0 to pi. It
Mm.
will never exceed pi, right? So that I wanted to explain you. So I think it's like it may be clear. So phi is going from 0 to pi, theta is going from 0 to 2 pi, and this is the coordinate spherical coordinate system. What is x square plus y square plus z square?
R
R
square.
square.
R,
No,
squ- R square.
no. What is r in this case? That's not r. Like r is on xy plane.
Oh, 5 rho
Rho is
square. Rho
square.
square.
Okay. So radius of the sphere,
Rose.
that is rho. So rho is square. So this is an important equation. Okay. So if we set up the triple integration here, so that like for the given region f of x comma y comma z dv, okay, we always take this order, like theta goes from alpha to beta, phi goes from 0 to uh, d, okay, and rho goes from some values to some value. It depend on the question. So basically, what order we have to follow here is rho square sine phi d rho d phi d theta. Okay, and the function maybe mass density function. Okay, so this order, like like we saw in the cylindrical coordinate system or the polar coordinate system, r is there with dz dr d theta, isn't it? R is always with dz dr d theta. Here we have rho square sine phi with d rho d phi d theta. We always go along d phi first. Okay, we always go along rho first, then d, then phi, and then theta. So that must be the order. I'll explain you why we are choosing this order. It's not that complicated. It seems complicated right now because I'm not drawn anything or I'm not explained this. Otherwise, it's very easy. So see, first of all, understand one thing. This spherical coordinate system is used to define the region which is like conical or the spherical. Okay, conical or the spherical or both. Okay, so what have you ever seen the picture which has both cone and sphere all together?
Mm, yeah,
What is that? Our favorite
like an ice cream,
delicious,
right?
yeah,
Ice cream cone, yeah, yeah.
yeah, ice cream
On
cone.
top this.
Yeah, so that ice cream cone has cone as well as sphere on top, right? So such figure can be easily integrated by spherical coordinate system. If you try to integrate with rectangular coordinate system, I'll give you that. I'll give you that to solve that by Z simple, the usual method. Okay, that we have been doing so far. You will find that it's really difficult to crack the triple integration with respect to cylindrical coordinate system or any rectangular coordinate system. Okay, but if you use the spherical coordinate system, the triple integration is going to be very easy in that case. So that's why we are using spherical coordinate system. Okay, believe me, I've tried that by solving the triple integration with by using cylindrical coordinate system. I found it's very difficult. I have to apply the trig substitution or the other the integration by part altogether, a lot of stuff. So that's why I think I should explain the spherical coordinate system also, so that you guys also don't find such difficulty while solving or simplifying the triple integration. Make sense?
Yeah.
So we'll do that. Okay. So let me explain this why we are selecting this order. Like why we have rho square sine phi with this. Okay. So to understand that, we have to find out the change in volume, right? See, we are finding out volume here. If suppose this f of x comma y comma z is 1, if the function is 1, we eventually end up with the volume of the given object, right? For the given region. So eventually we are finding out volume. So let's see, as far as just the region is concerned, we find out the volume. So let's find out the change of volume in the spherical coordinate system. Okay, because if you find out change in volume, then we can come up with this idea dv, the differential. Are you getting that? And how this triple integration like will be, what would be the order that will be revealed automatically. Okay, so let's find out the object, the region here in spherical coordinate system. So draw this region properly first.
So
Yeah,
that in the setup in your integral setup, square sine theta is basically rho into r, right?
rho into r.
Because rho into r
Yeah,
gives rho square.
yeah,
Basically, basically, right?
Yeah.
Yeah.
But that r is I just I wanted to take r because I want to explain like x is equal to r cos theta and y is equal to r sin theta. That's it. Otherwise, there is no use of r. That r is nothing but rho sin phi.
Okay.
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 So this is the spherical wedge I am drawing here. Okay, have you drawn this? This is spherical wedge. Now we are finding out the change in volume to have a sense of the triple integration in this. Because this change in volume will give you differential dv for the slight, like for the slight change where h tends to 0. I hope you can relate a lot of things all together here. So what is change in volume of this spherical wedge? That would be like arc length along theta. Okay, change in arc length along theta. Are you getting that? Let me write the change in volume. So the arc length along theta into arc length along phi into depth. Okay, this is how we find out the volume, isn't it? This is how we find out the volume of any spherical wedge. You can relate your concept over here. The arc length along theta, the arc length along phi, and the depth, right? That would give you the volume of this spherical wedge, right? Now since this spherical wedge, are you getting that? This is the whole sphere. You can understand this is the whole sphere. Now this is some part of that. If we are going
Yeah.
away from the origin, the volume is increasing, right? So what would be the change in volume that we are finding out here? What would be the change in volume? So the arc length means change in arc length along theta. Like I have already written down there delta theta. Are you getting that? So what is the arc length for delta theta? What is the formula if I give you this length of the radius? What how would you find out the arc length? If this is r, this is theta, how would you find out the arc length?
Theta and
R theta, right? The arc
Yeah.
length is r theta. Similarly, if I have to find out the arc length here, that would be what? Rho, okay, rho. Just a second. What is r? What was r here on xy plane? Let me write that r delta theta. That was rho sine phi delta theta, right? Isn't it?
Hmm.
And what would be this arc length, like this one along phi? Can you understand that this is the change in phi, right? Change in phi. Hmm? So what would be the arc length here along phi? Let me know the answer. Rho delta phi. The radius is rho.
Right.
Okay. And the depth is delta rho. Okay. Change in rho. So if I write all these entities for change in volume, that would be rho sine phi delta theta, hmm, into rho delta phi into delta rho. Okay. If you rearrange the term, what will you find? If you rearrange the term, you will get rho square sine phi delta rho delta phi delta theta delta v. So like for the small change, we get the differential. For infinitesimal change, we get these terms is converted into differential, and from there we get the idea of triple integration. dp d phi d theta. Okay, and like this way. Did you understand this? See, Mano, I find like you're a little
Yeah.
bit confused. You find this very difficult, maybe. Should I explain this again?
No.
It's simple,
Good.
right?
Good.
Yeah, okay. So you
Yeah.
just, yeah, you see the diagram. In diagram, like a lot of things are clear.
Yeah.
Sean, did you understand this?
Yeah.
They always understand. No need to ask it. Okay. So now I'll give you the question. You have to first, if you can apply the, if you don't believe me, I know like believing other guy is very difficult nowadays. So if you don't believe me, you just apply the the cylindrical coordinate system or rectangular coordinate system if you want, and check that the cracking triple integration for spherical coordinate, like for the spherical region, is very much difficult by solving them by a rectangular coordinate system or cylindrical coordinate system. Okay, that's why we have to understand this spherical coordinate system. It will like ease out our triple integration.
Mm.
Okay, write down the next question, the question based on this. Okay, I'll just give you the question. Time does not permit me. uh, X square plus y square plus z square in square root dv, the region t, the sphere x square plus y square plus z square less than equal to 1. Okay, I insist you to solve this by cylindrical coordinate system first. Okay,
Okay.
so this will be your homework, and if you find a lot of difficulty while solving that, because I have also tried that. I have also, where did I get that? Not able to find that. Okay, so I found a lot of difficulty. So you try that by cylindrical coordinate system and let me know what you get. Okay. And if you're not able to find or if you find a lot of difficulty, then use spherical coordinate system. Okay.
Okay.
Okay. So we'll stop here for today. We'll meet on Monday for the with the solution of this and the other stuff. Fine.
Yeah.
Was it useful? Like, did you really learned anything new today?
Yeah.
Yeah. Mano, you want to ask anything?
No, sir. Just today's notes on WhatsApp.
Okay, okay, fine. I'll send that. Okay, bye bye.
I'm still drawing that diagram. Yeah.
Okay, I'll
Bye.
send that. I'll send that.
Thank you, sir.
I'll
Bye.
send that.